Hey guys, I'm Shreyas and today we are in the 12th day of the July LeetCoding challenge, and the question for today is isomorphic strings. So probably this is one of the easiest questions on LeetCode because it's just based on mapping of characters from one string to another string. So the rule over here is that we just need to verify if one character can be mapped to the corresponding character at the same index in string t. For example, over here in the first example, E is mapped to A, G is mapped to D, and again G is mapped to D. So the rule over here is that one character one one character in S can be mapped to only a particular character in T. For example, in the first occurrence of G, first G occurs in the second index, so G is mapped to D, and again in the third index, again we meet G, but this time if G is mapped to some other different character, over here since both the times we have D, it's a valid mapping. Suppose we had different character than D, then it's an invalid mapping because the first occurrence of G was mapped to D and the second occurrence of G was mapped to some other different character, so it's an invalid mapping in that case. And another rule is that one character in T cannot be used to map two unequal characters in S. So if A is already mapped to C, we cannot map B to C as well. So one-to-one mapping it is. But different occurrences of same character can be mapped to the same character in string T. So that's the rule, and so the code is quite short as well. So first I used one set called used, which is used to store all the characters in T which have already been mapped, and then I use a hash map replace, which is used to maintain the mappings of S to T. So first I iterate through all the characters, and if we have not processed the current character anytime before, so there is no mapping of the current character yet, so then we have to map it. But if the corresponding character in T, that is T of I, if T of I has already been used before, then we cannot use that one to map the current character, right? So then we return false because it's an invalid mapping in that case. Otherwise we map Si to Ti and we insert the Ti to the set used, denoting that Ti has already been mapped to Si, and so in the future T of I should not be mapped to anything apart from S of I. So that is the case if the current character is not already mapped, and if it has been already mapped before, and probably this is the second time we are meeting the same character or something like that, then we have to check if the previous mapping is equal to T of I or not, because as I said earlier, right, only one character in T can only be mapped to the same occurrence of the S of I. So that's the reason we check this condition, and if S of I was previously mapped to something else other than T of I, then it's an invalid mapping and we return false. And if the condition holds good for all of the n numbers, we return true at the end. So the time complexity for this approach is O of n log n, because searching in set and map takes log n time, and we are processing all the elements from the beginning to the end of the array of the string. So that was the approach, and the space complexity as well is O of n. So that's it for the video, guys. Thanks for watching.